Swayam Prabha. Digital India. Educated India.
Today we will be talking about one of the classical ground improvement techniques, namely with cement. Stabilization using cement and cementitious materials is one of the standard techniques, because what happens is that many of the in situ soils, they do not have good bonding. So, if you want to increase the bonding resistance, use of cement or cementitious materials like fly ash. In fact, fly ash also has some sort of cementitious compounds that I will show you. So, stabilization using cement and admixtures such as fly ash, blast furnace slag has been adopted in many geotechnical and highway engineering projects, whether it is slopes or embankments or highways. These have been used very extensively, and the applications include shallow depth applications in case of ground improvement of subgrade, subbase and base course of the highways, and embankment material. As we have seen earlier, we used lime to increase the CBR and to increase the stiffness and all that. Here we can use cement as well, because many of the industry people are more comfortable with cement, though it is going to be quite expensive in many of the projects. But then people have been comfortable with the use of cement in many projects, and particularly right from 70s, lot of work has been done on the use of cement as a stabilizer or as a modifier in ground improvement. The other important point was that there are some places where the soft soil is so deep and very soft, and you need to construct something like a containment areas or some sort of big structures. So, you must stabilize deep soil deposits, maybe up to 10 meters. Like we have seen many other techniques which we had, like prefabricated vertical drains, then stone columns and all that. This is also one of the techniques. Like as I just said, prefabricated vertical drains, they stabilize the area by drainage, whereas here, for example, in the case of stone columns, they improve the overall bearing capacity because you are trying to put stone columns. In this case, instead of the stone columns, either you may put soil cement columns. That is the difference, and we will see how it is done. So, if you use small quantities of cement, like addition of small quantities of cement proved to be very beneficial, and the degree of strength and stiffness required is the basis for design, and has been used in stabilization of highways and embankments. Like we have seen earlier, that if the CBR is low, we add some sort of binding agent like lime, and the CBR increases. Similarly, we try to add cement as well here to see that there is an increase in strength as well as stiffness, both are required, because we need that bearing capacity to be increased, particularly in the case of highways and embankments. And sometimes this is in the case of shallow applications, we can call it a modification of the existing soil behavior, but in some cases where the large scale applications are there, we need lot of quantities. Of course, here also the quantities are huge, but compared to the cement stabilization for highways and like say for example, if you add some 10% or 5% of cement, and then it increases the bearing capacity, that is one thing. But here you are using large volume of cement, and say there the quantities required are huge, and we need large scale machinery, and special procedures are required for stabilization of deep soils which are weak. For example, here you may need a simple road spreader type of thing. In the case of lime stabilization, we have seen you need a stabilizer, you need a spreader, you need some sort of compaction equipment and all that, which is quite simple. So, one can stabilize the subgrades and subbases and all that, but here in the case of large scale applications, we need, say if you want to try to put some columns, we need to have some special type of equipment and procedures also, because it is not easy. Why I am mentioning this example is that particularly in areas like Scandinavian countries like Sweden, Denmark and many places, the soil is so soft sometimes it is particularly in Netherlands, in some places it is called PT soil. PT soil means organic deposit. Even in India we have a lot of organic deposits where the soil is the actually the problem with the PT soils is that they have very high organic content, and the settlements are going to be very huge, because not only because of the primary consolidation and the secondary consolidation, there is what is called tertiary third type of consolidation called tertiary consolidation, where because if the organic matter disappears, then there is another some more settlements that do occur. So, they are all very tricky, and people have used, in fact in places like Malaysia, and in fact in India also we have a lot of organic deposits. Organic deposits essentially come, so for example you can say that the organic content, organic matter content in coastal areas could be little higher. So, the settlement is also because of that as well. Say for example, Cochin marine clays, they have some sort of organic content, and one should be little concerned about these things. So, when you have organic, because when it is all area that has lot of trees and other things, and finally it becomes little more semi solid, and you want to construct a building there, definitely it is going to be organic soil. So, all these things need some sort of improvement, and we need to increase, as you said, like we need to have this sort of stability. The benefits are that as we know now that it increases strength as well as stiffness, better volume stability, like volume changes are not going to be very significant, which are reasonably within tolerable limits, and increased durability. So, this is what we will be addressing, and like we addressed some of these things in the lime columns and lime stabilization, we would be looking at some of these, they are all equally applicable, all these criteria and all would be equally applicable for even cement stabilization or stabilization with any of the additives. Okay. So, what are the factors that influence the strength and stiffness improvement? We know that cement content is one of the important variables, because soil, say for example particularly you are taking sandy material, it could be somewhat coarse grained, and if you add bit of cement, it becomes little more, it binds the particles and it increases cohesion. So, when you add cement content, you also need to add water, and water content is because it is required for heat of hydration and all that. So, water content as well as cement content are important, and we call it in terms of the water cement ratio. Then the method of compaction, see the thing is there are different methods of compaction that we have in even in whether it is shallow or deep, that also is an important factor, because essentially we need to have the proper equipment for the compaction. So, the other important point is the time elapsed between mixing and compaction. If you mix a cement plus soil, then you take it later for compaction, that difference also matters, because the heat of hydration is an important variable. Then the length of curing, actually we are all familiar with cement concrete, and the curing is very important because availability of water is important for curing or the hydration to take place. Temperature and humidity are some more important parameters that are quite significant in attainment of strength and stiffness required. Particularly when you are trying to do in the laboratory, the specimen size and boundary effects are also important, because the thing is that whatever say you are trying to do, it should represent the field conditions to the extent possible. If you are not able to do that, then the test results that you have in the lab need to be really corrected or understood in a proper sense, to see that they represent the field conditions and also give you proper guidance on the design or the performance. For example, there is a simple equation that gives you the strength gain. In fact, Professor Mitchell, James K. Mitchell, who is a well known authority in soil mechanics, has proposed a simple equation of this form, like the UCC strength at any time is a function of the UCC strength at the beginning, like T0 days plus K into log T by T naught. It is a simple exponential equation, and K is nothing but it is about 480 C for granular soils, 70 C for fine grained soils, and C is the cement content by weight. There is some sort of information that he was able to compile, but then one should really understand that the strength gain is a function of the time, as well as the type of soil in from this equation, nothing more than that. But one can really check in this actual cases what is the actual relationship. In fact, a lot of work is done in laboratory scale in India on these lines. What happens when you add cement to soil? Say, in fact, even blast furnace slag also has some sort of cementing agent. So, it has some the chemical reactions like this. The hydration of cement produces calcium hydroxide. The calcium hydroxide generated is up to 25% of the weight of the cement. It is actually a cementation, this calcium hydroxide is generated, as we just saw in the earlier case. There is a, it encourages H2 phase flocculation and some of the things we have seen, and absorption of calcium hydroxide by the clay and cation exchange also takes place. So, the addition of cement is similar to lime, except that it is much more I mean, like the mechanisms are somewhat similar, but then there is some more addition here, like sometimes even the pozzolanic activity is also another important variable that comes in here. If the clay is saturated with calcium hydroxide, a pozzolanic reaction between the component occurs. What we see is that, say for example, there is an optimum lime content in some case, like you have an optimum moisture, optimum lime content, beyond after that it decreases. So, you have an optimum content. In this case of lime, there is a continuous increase of strength, but then we can't just go by that. We have to really see if you add say 5% or 6% or 10%, does it really give you required engineering properties is what you are interested. So, if you are trying to put these reactions in some sense, like you have the absorption or the cation exchange reactions, then see water plus clay particles, they have this sort of reactions, and when you add Portland cement and you have a hydration taking place, and we have also seen that its aggregation takes place, and some of these things we have seen, and it leads to some sort of reaction products which are like this CSH, CAH, CASH. Here also same thing here. In the case of CSH, CAH, CASH, what do they mean is C stands for calcium oxide, S stands for SiO, aluminum, A stands for aluminum oxide, H stands for H2O. So, these sort of compounds do form when you have this sort of, say for example, the hydration and some of these reactions happening, and you have these materials make the soil stiff, they harden, they change their properties basically, and now it is a better engineering material. Like if you want to use that, you can use it in a properly. So, when you are trying to design a soil treatment project, for example, you know that the soil in this area is very weak. So, but then what should be done? Say for example, the government of India or whatever, they are planning to have some sort of soil treatment project in some area which has lot of soft soil deposits or expansive soils or whatever. So, one should do soil investigation, so site exploration, which will give you what are the geotechnical conditions that do not meet the design criteria, for example, density, consistency, strength and permeability, whatever. So, one can have to look at all these numbers of the in situ system. You have a soft soil in there in the particular area, maybe you imagine a highway is coming up for about 100 meters, 100 kilometers connecting two villages which are having soft soils as a foundation, the soil medium there. So, essentially you are looking for many of the engineering properties there, and once you know that the engineering properties do not meet the criteria, then you have to see that they improve those properties in a proper way. What should be done is that you need to look for alternative treatments. So, what are the alternative treatments? We discussed many, say for example, one can use lime, one can use cement, one can use stone columns, one can use prefabricated vertical drains and all that. So, in a project what we should do is that we have a number of methods of doing this, but which is more comfortable, which is more economical, which is more where you have contractors who have experience should only be considered. So, there are many issues there, because finally you are trying to deliver the project in some sense in a complete form without any difficulties and delays. This is very important. So, what we do is that we have alternative treatment methods which should be evaluated in a particular project. Specialty contractors are selected. Say for example, lime stabilization, it has a special contractor, or a cement stabilization, it has a special contractor. So, you need to get them the information and how they do the work. Say for example, you can in fact one can say that this is my requirement, and how do you use your technique to stabilize this 100 kilometers area, and what are the techniques you have, what is the cost, say what is the method you are using. So, one can ask, and then they come out with some sort of quotation, what you call quotation, and all the specialty contractors will be able to select give their information. Now, say for example, what should be done is that it is always advisable to conduct some sort of laboratory mix testing. Suppose you have Cochin marine soil, take it and then try to find out the in situ properties, then try to find out how the properties are improved with addition of cement or whatever, lime or admixture in some combinations, and so you try to come out with tolerable admixture properties and optimum mix designs. So, come out with what are the mix requirements. Say for example, the settlement of the completed embankment should be minimum in this number. So, what is that it gives? So, you have to go for the mix design and to come out with, say for example, if 10% of the cement will give you that settlement, then you have to go for that. So, it is something like that. Then owner approves the contractors, equipment, methods and mix design, because there are so many people in this particularly project where you have a owner, say for example, the government of Kerala or government of Andhra Pradesh, who are trying to construct some roads in a particular area. So, they have to be comfortable, they have to be happy, and they have to understand what exactly they are trying to do here. So, owner is one, then the designer is one, because designer also should know what exactly he has the problem at hand and give some sort of optimum solution. Then the third one is the contractor, and then the treatment, particularly ground improvement experts. So, the contractor sometimes may not have experience with him, so he will use the ground improvement consulting agencies or even construction agencies as some of the subcontractors, and they try to quote for a particular project. So, the owner should be able to understand, contractor should be able to understand, designer should be able to understand. In general, if the owner agrees that yes, the contractor can deliver this job, and if the mix methods are also okay, in the sense that they do not lead to delays. So, there could be some methods that is done in abroad, but they may not be possible right now in India, because the thing is that even to get an equipment it could take 3 or 4 months to, say for example, in Netherlands people have a lot of experience, but if you want to use do in a project, then they may not be able to get the equipment, so the equipment could cost about 3 or 4 crores. It may take some time to get some of these materials, and they are all most of the equipment are very expensive. So, the owner should be able to understand the contractor's equipment, methods and mix design. Soil at site is treated with close supervision, that is very important. Sampling and testing in the field to make sure that the project requirements are met. So, what should be done is that once the contractor is chosen, then its work is started, the work should be supervised very closely, because any slip there could lead to a lot of difficulties and you can't go back. There are many situations that I was able to see where if there is a slip here in this supervision, or if the supervising people do not know exactly what it means, then there will be a lot of issues there. So, one should be knowledgeable in that, and then they should supervise properly. Then sampling also. So, for example, sampling is required because you have an undisturbed or a pre-treated soil and soil after treatment, how is it is performing. So, we need to test all of this and then make sure that the project requirements are met. So, I would like to just give some information on the some information laboratory test results. It is a Bergado et al. In a paper. They did lot of work, actually whole of Bangkok and Malaysia, you have a lot of soft soils, if somebody goes there, it is mind boggling, in the sense that there is so much work on ground improvement there. All the airports, all the projects are all having lot of ground improvement techniques. So, the results what he showed was that for the Bangkok clay, which is a very soft actually, 10% of the cement was added, and they observed that the unconfined compression strength increases by about 10 to 20 times. Say for example, the value may be 5 kPa in the initial, it increases to 50 kPa, maybe 10 kPa it becomes 100 kPa. So, there is a good improvement strength because of the addition of 10% lime, and also the pre-consolidation pressure, like we know that the settlements are very important. If the pre-consolidation pressure is higher, the settlements are going to be lower. So, it also increased by, say for example, instead of 100 it becomes 200 kPa, or if it is 250 kPa it becomes 500 kPa, like that. So, the pre-consolidation pressure also increased very well, and the coefficient of consolidation improved by about 10 to 40 times, because again one can also calculate the consolidation, and as I just mentioned, the mechanisms that we discussed already, like catenary exchange formation and cementation formation, flocculation of flocculation, and then formation of this what you call the flocculate structure. Some of them are examples here, which will make you, which will make the cement plus soil. In fact, we call it soilcrete. You know, it's not sometimes called as instead of concrete we call it soilcrete. So, some people use the term. So, they considered about 10 to 15% of the cement content as optimum, and they did lot of work. Okay. For example, this is an important observation that they have made. The cement content actually it is about 5% inactive zone, because it needs some time, and once we start increasing 10 to 15 and all that, you know, it continuously increases, there is no problem with that. It is T at 1 week, and then it is 24 weeks. So, but then one can see that a cement content in this range 25% could be all right, like, which means that this is a zone of very active reactions and all that, it is very strong, but then in the field you may not need that much. So, 10% may be sufficient. Say for example, you want a good bearing capacity, you do not need to go for 25%, 10% may be sufficient. So, that is what I want to say, that one should be able to choose. These are all required from the laboratory point of view, and when you are trying to choose, we should choose what we need and get back that information and then use it in the design. That is what is required. So, this is another example, like this is axial pressure and then this is a void ratio. Okay. So, you can see that the again the cement content is higher. So, untreated clay, the E-lock P curve is like this, is very steep, but you can see that of course this is a volume change, actually this is all volume change. Okay. So, you can see that after 1 month, 2 months, 3 months and 6 months, they did you also have E-lock P relationships. You can see that they are in a narrower band. No, there are time effects, of course, like you can see here that 1 month it is somewhat like this. Yeah. So, you have a variety, definitely you can see that compared to this where there is a significant volume change, these values are quite okay, in the sense that one can say that the settlements are going to be minimum. Like this is what we mean by, you know, if you just the pre-consolidation pressure is also a little higher, like, you know, how do you get the pre-consolidation pressure? You just draw the tangents on either side using the Casagrande method. So, for example, in this case, if you do that, maybe you will get about 80 kPa or something like that. But the same thing if you just drew here, it could be about, you may get about 500 kPa. So, that could be one ratio of improvement that one can expect. There are some more studies people have done on, particularly in the field scale. As I said, soil cement or soilcrete is an excellent combination, and it was used for, you know, in a particular coal dumping area. They have used this particular material, and to essentially for retaining berms, you know, what happens is that you need to retain lot of coal material, and unless you retain them in a proper way. It's very they occupy a lot of spaces, and they have given that about for 25 years these methods have, in the, as I said, in the olden days people were only knowing about cement stabilization or lime stabilization. So, some people they add lime, some people they have added the cement. So, in this case it was reported in 89, and then they said that they have observed for about 25 years and find that the cement soil was an excellent combination. How did they do that? In fact, they had a pug mill. In fact, there are so many equipment nowadays, mixing, it has some sort of mixers and all that. So, you add soil and cement, and then add some required amount of water, and then for hydration purposes, and the soil is ready, and start putting it in the paver. Okay. So, you can use it and dump it, and construction embankment can be done. So, this is another study, some result they have observed. Actually, ASTO has a different type of soil classification, in which they say use A1 to A8 type, A1, A2, A3, A4, A5, A6, A7, A8 types. A1 represents a good soil, and A8 represents a poor soil. So, the increasing order of difficulty is indicated in that manner, and in this case, in whatever they have tested, say if the soil is A2 type, and if you add 8%, the cohesion, the thing is that cohesion has improved to this range 130 to 690 kPa, which is quite good. And because their objective was to this coal ash material, whatever they would like to pile it, or they want to store it properly, they were able to use a slope angles of 29 to 49 degrees. Slope angles are, say for example, if you 29 is increased to 49, that is what it means. Originally it was a 138 kPa, and it got increased to 690 kPa, and the slope angle at which they were able to store was from 29, it was increased to 49. The soil A1B type is another one, is about 5% was added, and its 69 was initial, like whatever is the number you have, and it increased to 655, something like this. So, 38 to 55 is a good difference, and A4 is something very poor, little poor compared to these two, and you can see that the cohesion improves from 5 to 125, and the friction angles are in this manner. What it means is that, like I will show you the diagram, like this is a compacted fill, and so using soil cement they are able to go for steeper angles. Otherwise, what happens, only compacted fill cannot be very steep. So, if you have a material like this soil cement, it is a good cover, and its angle is 55 degrees here. So, this is what they have done that in their area, and the other one was that in some other place, like they have to construct a berm. Say this is a soil cement area block, and this is a granular material. So, this is another one they have used in some place in soil cement as well, in some of their same project, in the same project. This is another interesting example where soil cement was used, instead of the regular retaining wall. Okay. You can see that instead of regular retaining wall, one can use this soil cement as well, which is quite useful. So, in the case of say for example, this is again a soil cement block, in fact that is also quite useful. So, instead of the poor soil, they used a soil cement block here, soil cement material mix actually. Okay. So, it was quite helpful. So, what the study showed was that the costs were very competitive compared to conventional retaining walls or even any of the shoring systems. The ease and ability to shape a soil cement in the variety of configurations to meet the project demands was useful. Actually, because of the cement soil block, it was able to, you can put into any shape that we have seen, this is one thing, this is another case where you are able to handle it well. So, the use of cement plus soil has been quite effective in many of the stabilization projects. What I will show you now is a sort of this use of cement for shallow stabilization, it is very clear. But then when you are trying to use for deep stabilization, so again people have been using it without they have been doing very well, because that is a necessary there. Like if you're trying to particularly in if you go to Sweden or in many of the institutes, they have what is called Swedish Geotechnical Institute. If you go to Finland, they have Finnish Geotechnical Institute. Then you go to Netherlands, they have got Delft Geotechnical Institute, Delft Geotechnics they call it. Or if you go to Norway, they call Norwegian Geotechnical Institute. So you have varieties of institutes, very good institutes, which are just working towards just exclusively on these problems. They give they are doing very practical work on these lines, practical advanced work as well. So particularly even in Japan, in many places this was done, and most frequently soils are mixed in situ with cement and or lime and using a specially made machine. This method was developed in Japan and the Scandinavian countries, as I said, in 1970s itself. People have been because after the two world wars, people are looking for development in their own countries, and when you want to try to development, your only roads are one alternative, embankments, bridges and all that. So when you are trying to have soft soils, only alternative is that you have to improve soil. So deep mixing methods are called in different names, but they are called deep cement mixing or DMM. So this is a standard deep mixing methods they call it. This is one way of addressing the issues. So I want to show you what are all these methods, like soil mixing methods, deep mixing. Actually it can be uniaxial rotation, rotation of the whatever is the mixing device you have. So it can be a wet mix, it can be a dry mix, and say for example in the case of wet mix, it can have single or multiple shaft or single or multiple blades, like I will show you in a video now. Or so it can be multiple non-interlocking augers, essentially it can be of shafts and augers, and dry single shaft or multiple blades, multiple shafts. So you have some sort of mixing procedure here, and you can even have hybrid mixing methods where it can have uniaxial rotation plus addition of water, adding water, uniaxial rotation plus linear translation, some sort of movement, in plane rotation plus linear translation. So there are certain ways of doing it, particularly it all depends on the type of equipment you have. So for example, some company may find that that's a better way of doing it, some company may say that this is a better way of doing it. So mixing again has lot of different types of equipment. It's just that you should know that there are so many methods, that's then it's very important that they are available in the site, and we should understand what it does. So wet again single shaft and all that, we have some sort of dry single shaft and blade and mass stabilization. Ploughing is also possible, like when it is dry you can plough. I just before I try to cover some more points, one should understand in this particularly how do you design in the case of a deep mixing project. One is that you need to know what is the design strength of the area.